Hi, I'm Hoon Oh, and this is my physics project, the physics of tennis. Tennis is known to be one of the most popular sports that is played around the world. Tennis is a very global sport, but is known to be most popular in areas of East Asia and all across of Europe. The origins of tennis did not start off as a set sport, but had influence from other sports in the eras. The earliest recognizable relative to tennis as we know it was jeu de paume, played in 11th century France. Played in a monastery courtyard, the game used the walls and sloping roofs as part of the court and the palm of the hand to hit the ball. Later in 1873, Major Walter Wingfield invented a game called sphäristike, Greek for playing ball, from which modern outdoor tennis evolved. My involvement through the sport of tennis is how I've been playing since the 7th grade and have been a part of the Northville High School varsity tennis team since sophomore year. Physics is all around the sport of tennis. A very important aspect of physics for tennis is how gravity is involved. Gravity pulls the ball towards the ground, slowing the ball down so that each bounce is shorter and shorter until eventually the ball stops bouncing. The force of the ball hitting the hard ground puts an equal force back onto the ball, causing it to bounce up. This happens because the tennis balls are made out of an elastic material like rubber, which means they can be dented or stretched and then return to their normal shape. If the tennis ball was made out of something softer like silly putty, it would be squashed on the ground and wouldn't bounce. If the ball was made out of something harder like glass, it would hit the ground and break. Physics is also used for different executions of shots like the serve, topspin, and backspin. For the tennis serve, as the server bends down, they gain elastic potential energy. As the server pushes off the ground, potential energy is converted into kinetic energy, and then the server rotates their body for maximum angular acceleration of the racket. Here is a video clip of professional John Isner serving the ball. To hit a ball with topspin, a player rotates the head of the racket over the top of the ball during the hit. This exerts a torque about the center of the ball that causes the ball to rotate with a forward spin during its flight. As the diagram shows, topspin is characterized by the tangential velocity of the top of the ball pointing in the same direction as the trajectory of the ball. Hitting a ball with topspin causes a Magnus force to act on the ball perpendicular to the velocity of the ball in the downward direction. Because there is an additional downward force on the ball, tennis players can hit the ball with a greater speed and have it land on the court if they apply topspin to the ball when hitting it. In addition, balls can be hit higher above the net, making the shots more difficult to return because the addition downward force pulls the ball downwards. This also results in a higher bounce for the ball. To hit a ball with underspin or backspin, a player angles his racket back and slides it underneath the ball when hitting it. This type of shot is called a slice. It exerts a torque about the center of the ball that causes the ball to rotate with a backward spin during its flight. As this diagram shows, underspin is characterized by the tangential velocity of the top of the ball, pointing in the opposite direction as the trajectory of the ball. The 3 Newton laws are used frequently in the sport of tennis. The most obvious instance of Newton's first law is the path of the ball. When you smack the ball with your racket, it heads off in a certain direction. If you were playing the game in space, the ball would continue in that direction more or less indefinitely because no external forces would be acting on it. On Earth, however, 2 major forces are at work. The air resistance slows the speed of the ball, and the gravity pulls the ball towards the ground. Newton's second law is force equals mass times acceleration. In this equation, mass is measured in kilograms and acceleration in a unit called meters per second per second. When serving the ball, Newton's second law can be used as having the tennis balls as a constant mass and adding to the theory of the more force on a serve, the more acceleration. Newton's third law informs us that the force exerted by the ball on the racket is equal in the magnitude and opposite in direction to the force exerted on the racket by the ball. An example of this is shown when a player hits a volley or a shot in air. The impact created by the ball on the tennis racket strings will equally produce the same amount of force, and the ball will bounce back to the opponent with little effort. Well, that is the end of my presentation. I'm going to put my tennis racket in my bag and go now. Thank you for watching, and I hope you learned a lot about the physics of tennis.